the net force and the net torque on an object is zero, we say it's in equilibrium. And if it's also true that there's no motion, then we say it's in static equilibrium. Static means it's sitting still, and since there's no net force and no net torque, it will continue to sit still. So that's what you mean by static equilibrium. And even then, there's this distinction. Is it stable or unstable equilibrium? So sometimes it's obvious, and sometimes you have to think a little bit about it. Let me just show you an example of a complicated shaped object, and let me hang it, and let's just ask what kind of a state is it in right now. It's not accelerating. It's not angularly accelerating. So it must be, by observation, that it's in equilibrium. And I claim that it's in static equilibrium, it's sitting still, and it's stable. Stable means that if I perturb it a little bit, if for a brief moment it's not true that the sum of the forces or the sum of the torques is equal to zero, it will return back to its previous equilibrium position. There's some extra force here of friction, but in the end, right now, there's no net force, no net torque, and you can just see that this is a stable configuration. There is another configuration here, another way I can set it up from the same pivot point with the same object, which is also technically static equilibrium, but it's not stable. It's very difficult for me to do. It's a balancing act. And, you know, no matter how hard I try, it gets really close to being balanced, and then it runs away. Technically speaking, there really is a balance point. I can, in principle, get that object balanced so that some of the forces is zero, some of the torques is zero, it's not moving, it's staying up there, it's in static equilibrium, but the tiniest motion, the tiniest extra force for even a brief moment moves it out of equilibrium and it runs away from that position. So that's an unstable equilibrium. How do you decide, how do you know whether something is going to be in stable or unstable equilibrium? Clearly important when you're designing things. You want to know if a little perturbation is going to make them fall over or not. So here's a picture of that funny shaped object. Here's the pivot point, and then there's this object which I could have in any orientation that I want. And what I really am interested in is this thing going to twist around and fall? So here is going to be my origin. And I'd like to figure out, can I make the sum of the torques equal to zero? That's certainly a necessity if we're going to have equilibrium. So what's the sum of the torques on this object? This object is made up out of a bunch of chunks of mass, m, which we could label m sub I. And, you know, it's a little bit of a complicated problem. I have to figure out the torque. What's the force which is causing this thing to rotate around? It's gravity. I'm just talking about an object hanging. So it's the gravitational force on